Oh, I know what you're talking about.
All right, questions on the homework. At least you're in tune.
Number 5. Guys, we should have been performing.
We should have been.
Who went to the first? Who was at the first one?
Me.
When they were doing that one rap singing one, did like audio?
That's
come out?
everyone's all the
Yeah.
same one.
No, it didn't. Not for the rap one.
It was really funny. Oh, not the rap one.
Oh, no.
Yes, when the Purdue University came up, that was
Oh,
funny.
I didn't watch the end.
Oh no, it like finished and they forgot to stop because I think they were playing it on YouTube or something like that. And then an ad for Purdue.
All right,
I was like, someone clearly doesn't pay this one.
so we know that this is our enthalpy for the entire thing. We're going to take our products, which are here. We don't know what the water is, so we're going to put an X there, but we need to multiply it by 3 because of the coefficient. And then we have the Fe2O3 here, so we grab that value and put it in here.
Oh, okay.
Wait. Let me look at this again. So we don't know what value?
That's why it says what state is the water in. Water is H2O.
Oh, so we're using 96. Oh,
96.4 is right here.
and then you just, okay, yeah, that makes sense.
So I'm putting X in for the value of the water.
Oh, so we were just trying to figure out if it was liquid or gas.
Mm-hmm.
I get it.
That's what
Not good enough.
that's what state means, solid, liquid, or gas. It could also be plasma. We don't really deal with that in this class. But Bose-Einstein condensate.
So, if we're taking a test, sorry, Libby, we're taking a test, and it gives you a bond stuff.
If it gives you, if this is delta F sub or delta H sub F, you're going to do broken minus formed. And the way you remember that is that on here, they tell you delta HF is products minus reactants. So if your products minus reactants, then that's the one that you're going to be using.
Perfect. So, all right, because I didn't know if they were gonna. I forgot they were gonna give you those values. So I was like, how are you supposed to determine if it's
Okay. All right. So anything else for the homework?
I think we're good.
Okay. Just want to verify here real quick. Yep, I am recording. We're doing good. So I want to switch over to, these are the last notes, and there's only 4 slides for today. So getting close to being done with unit 6. Then we go into unit 7.
We have a
I
final.
won't do that bad on this test.
What do we do? It was on Monday.
Can we please just only do chapter 6 for the final?
No, I've already
Pay you
printed the whole.
$35.
You'll pay me $35. No, no. I do not accept bribes, guys.
I'll pay you.
You're literally being recorded, right?
I will buy your lunch for the entire. I will.
No, first.
I will.
The whole second.
I will never tell ever again.
We have our debit cards.
Yes.
All of them. Every single one.
Use our parents' money. Yours has your parents' money?
Well, yeah, it's like attached to my first account. And then I asked for like $20.
I mean, I have a job.
I don't have a
All right, here we go. We are talking about Hess's law. And this was Henry with an I. Henry Hess. Henry with an I.
Does that make sense?
Oh.
Is that German? Like, where's your name? Germaine. Whose name isn't Henry?
Oh, maybe it is Jermaine Henry.
I thought it was like Germany. It was like German, German person. He's like, this guy's German.
Yeah, I don't know.
Maybe Henry's his last name too. He has 2 last names.
I just wanted to let you know that like, we talked about the notes for maybe like 20 minutes, and the video's 29 minutes.
It is, yeah. He was Swiss and Russian, apparently. All right, off on that tangent.
Did you kill it? Yeah.
Was it like?
All right, getting back. Okay, so we are talking about Hess's law, and it states that the enthalpy of a given chemical reaction is constant, regardless of the reaction happening in one step or many steps. So we're getting back to multi-step reactions. Remember when we had elementary steps that led into the overall? We're combining that information from Unit 5 with information from Unit 6, okay? And applying that to thermodynamics. So if the chemical equation can be written as a sum of other equations, the enthalpy change of the target chemical reaction will equal the sum of the enthalpy changes of the other chemical equations. So if you have a multi-step reaction like A and B, right? So this is step 1, this is step 2, and your overall reaction is here, overall, then you would have A plus B will give you your, if you know the enthalpy here and the enthalpy here, you would add them together to get the overall. Make sense?
Yeah.
Easy enough?
I think I get it.
Okay,
Oh, okay, got it.
good.
Yeah, like.
Okay. So Hess's law then is based on the idea that the enthalpy is a state function, which means that, which is beyond the scope of this, but the idea is essentially that the numerical value of the property doesn't depend on the path that you take. Okay, so if we're going from Janesville to Madison, I could take a couple of different routes. I could take I-90, I could take Highway 14. I'm still going to get there. It doesn't matter which route I take, I'm still in Madison. That's kind of the idea of a state function. It doesn't matter how you get there. Okay, if you take 2 steps or you take one big one, you're still going to be in Madison. All right. So these are the key ideas for Hess's law. The reactions must add up to that target or overall reaction. If you reverse a reaction, so if you take this guy as written, and let's say that its enthalpy change is A kilojoules per mole. Okay, if we reverse that and have H2H2O yields 2H2 plus O2, then the answer is going to be negative A kilojoules per mole.
So if it's negative, it goes on the product side. If it's positive, it goes on the or if it's negative, it goes on the product side. If it's positive.
No, sorry.
The delta H, when you put it, if you write it into the equation, if it's negative, you put it on the product side and change the sign to positive. If it's positive, you just put it on the reactant side. I mean, it makes sense to me.
It
I'm
does.
gonna stick with
So
that.
if you're going in the reverse direction,
Yeah,
I have to
that's
just reverse the delta H value.
You just reverse the sign.
Okay.
Okay. Now, sometimes to make this work, you have to multiply to change coefficients to get things to cancel out. Do you remember having to do that previously? Same thing holds true here. Then you end up just multiplying the delta H value by whatever coefficient that was. So if we were to have to take this and multiply the whole thing by 2, then we would take our A here and multiply it by 2. Easy enough?
Yeah, and then when we get to the homework, I'm like, okay.
Sometimes the
You
words
multiply
don't
the
make sense,
table
but then
and
you
match the target reaction.
really help.
What's the target reaction?
Overall reaction. So for example here, this is your target reaction here. They're giving you these reactions to work with, and this is your target. You're trying to get to this. So we need to manipulate these in some way that everything will cancel out and all that's left is this stuff. Okay? So I want to end up with NO2 on this side. And I want an NO over here. So I'm going to take this guy and I'm going to flip him around.
So, I'm a little lost.
Okay, this is our target.
That's what we want it to be.
Yep, this is our target. We've got to take these. These are our steps. Step 1, step 2, step 3, essentially. Okay? But they're not in the right order necessarily.
Okay.
Because these are showing these things forming. Okay? So we may have to flip them around to get them to work for us. Okay? So I know, for example, maybe this is a better one to start with. We know for sure that the only one that water appears in is this guy right here.
Yeah.
Okay? And we know that with him, he's got to be on this side. So we know that he's going to stay the same for sure. Okay? So I'm going to go ahead and write him down. And I write his value off to the side so I can keep track of what I've done with it. I didn't change anything here, so that value is going to stay the same. All right, now I've got to get this NO2 over to this side. So I'm going to flip this guy around.
And then it becomes a positive delta H.
Yes.
Okay.
Oh my goodness. Why did you leave a big gap?
Because I want to try to keep my
Okay.
I want to try to keep my reactants and my products kind of lined up. It's just easier for my brain to cancel stuff out in the end. All right.
That makes sense.
And the last one says the same thing.
No, it flips.
Oh, it does, but,
So this guy, I need to, what do I need to do with him?
You need to, don't you need to?
N2s are going to have to cancel. So I'm going to have to flip him around because I don't want any N2s anywhere. And I need to get rid of,
You already flipped the one with the O2s. So you got that. James, did you
N2.
didn't know what we're doing?
Yeah.
They didn't know.
Okay.
Because they all live in Harlan.
Look at those triangles.
Especially here at like,
Remember when Patrick Jones?
No, I live at three.
Ceiling and then he swore.
How about self-contained?
At your house or at
What? Thank you. Although you won't start a streak first.
You look so gorgeous.
You told me
You
that
look
I.
like Meredith, alright.
You're so gorgeous now. You told me I should.
Remind her that you
Why
look
you get it?
like Meredith.
That was
You
so.
don't.
I got my super $30.
All the blades. Yeah, no.
Pretty couple.
Never mind.
All the blades cost like. No, stairs didn't have a blade. I didn't know.
By doing
Okay.
No, this is like one section for like.
And then I said, and she was like,
Double
"Oh,
blade.
All right, I've got to get this guy turned around to get these oxygens to start to be able to cancel. And then I'm going to have to run through a little bit more algebra here, okay? So I'm going to flip this guy around. So 2NO, and that's going to be 2N2 plus 2O2. Oh, no, not a 2 here. Sorry, my bad. There we go. Okay. All right, we got that.
Wait, 2NO, those two,
Here,
N2.
because I screwed up. There, better?
Yeah.
Okay. All right, so what's wrong?
I'm just confused. What's happening?
I flipped this guy around because I know that I'm going to have to cancel oxygens out. They've got to cancel out, okay? Because they don't appear in the overall reaction.
So would you
So
have to,
I've
like,
got to get rid of them.
would you have to multiply the equation by 5 to get rid of it?
I kind of get it.
Okay, so
So it was also between the 8,000.
I know, it's so short. Yeah.
I can't, my calc can count flip. So I go to 4th hour.
Oh my goodness, what are we gonna do in calculus?
Yeah.
4 hours, only 1 hour.
That, what's first one?
Wait, what?
All right.
Like the class
I,
of 4 hours?
am I going first?
all right,
Just like, they just,
So-
like, change the electrical something.
Yeah, we have first.
I'm going to divide. I need to get this guy here. I need- Are you guys listening?
Sorry, Jaden's talking to me about XX.
I need to get this guy so that I only have 1 and 2 here because I need these to cancel. So I'm going to take this. I can either take this guy and I can divide everything here by 2, or I could take this guy and multiply everything by like 5. Okay? Okay.
Wait, what? Why are we doing?
But then I got to multiply everything here. Let's just divide this by 2. Okay? Yes, we're going to have fractions. Get over yourselves. Okay? I'm going to take everything here and divide by 2. Okay? So this divided by 2 is gone. This divided by 2 becomes 5 over 2. This is gone. And this becomes a 2. What happens to this?
Divided by 2.
Divide by 2. So when I divide that by 2, it ends up being
1.
128.
all right. What did I do wrong then?
Yeah.
Right, 128.
Yeah.
Wait, are we only dividing by 2 for that?
Oh yeah, I was on the wrong step. Yep, 128. My bad.
No, you're not correct.
Lily can't do math.
Okay, better.
I need to find this.
Lippy's better now. Okay, sorry. Didn't mean to scare you.
Not good on that compass.
All right. I have 2 oxygens over here and 2.5 here. So I want to get this guy up. I need to add another oxygen in. Okay.
Wait, why can you do that?
No, guys, it makes sense. Just give it time.
Wait, I did it.
Matt, do you understand that?
I get it, guys. Just see, because you have the 2 O2s, but you're canceling out.
I gotta get this up to get this. I need to get this to 3 over 2 so that I only have 1 oxygen left. I need to get this to 3 over 2 so that 3 over 2 and 1, which is 2 over 2,
Yeah, which would cancel.
Oh,
which will cancel out as 5 over 2.
Okay.
Okay,
What are you trying to cancel out right now? The 5 over 2, so 2.
we're trying to cancel this guy out.
So it turns into 1.
So I need 5 over 2 between these two things. Okay. All right.
5 over 2.
Now, which one am I going to choose? Which oxygen am I going to choose? Well, I've got to have this N2 gone, which I have right now. So I don't want to mess with this line because we're already canceling stuff out like we need to. This guy is going to be gone, which we need to get rid of. And this guy is going to be gone, which we need to get rid of. So I don't want to mess with this line. I'm going to choose to mess with this line.
Got it.
All right. So that means that I need to multiply. This is really 2 over 2, O2. Does that make sense?
Yeah.
Right now, as we sit here. Okay. So I want this to be 3 over 2. So if I have this as a 3, and this is a 3, and this is a 3, okay, this will become 174.
Oh, this is 200 like self-made, right?
Hey,
Wait,
Libby,
what did we add?
Libby, when you were, back in your college days learning this, were you confused?
Probably, I don't remember. It's been too long, honey.
Yeah.
Because this is like different level thinking.
She works like everything but real.
Like it is.
Oh,
Oh,
that makes sense. Okay.
So that
You know what I mean?
3 over
Are we done now?
You're giving me blank stares here, Lippy. I don't know what.
Oh, okay, that makes sense.
3
Yeah.
and 12.
Did you like homescapes?
I don't know anything about homescapes. I just took her phone away. I don't know.
Lippy, it's like a more
like
advanced
Candy
version of
Crush.
Candy Crush.
It's so fun. Can you join our team, please?
Little Ellie Whip.
All right. So now this, remember, this is 2 over 2. Okay. So this guy is going to cancel and take this down to 3 over 2. And this guy will cancel and take care of the rest of that. All right. This guy's going to cancel. He's gone.
How did this work out?
Oh, because I thought you wanted to.
Oh
This
my
is-
gosh, it worked out.
This is going to cancel down to 1 and get rid of all of that.
It actually worked out. That's not even fair.
Whoa, how did that work?
Lippy, you blew up mine.
So are they all going to be this challenging?
So
No.
you just add up those enthalpies and then you got your answer.
So you've got this. You've got this, which is our 2 parts there. There's nothing else left over here. We've got this guy here. And one of these.
For the bottom one, can you cancel
Okay.
out that enthalpy or do you have to?
Nope.
add it
You got to keep it in.
in? Alright.
How we just add them all?
Add them all up.
What's that add up to be, Lippy? So it's an exothermic reaction.
It's exothermic.
485.
Is it kilojoules or is it kilojoules
Am I
per
there
mole?
second?
It'd be per mole reaction.
Per mole. Alright, that was the 2 shaft.
Well, no, I get it, guys.
That's the hardest it's going to get.
Okay.
Would you rather me do the hardest problem for your display and then your homework is easier? Or would you rather have the hard one for your homework?
Hard one for that.
Exactly. All right, let's do another one. So here, I need this as, where's my pen? There it is. I need this as my overall reaction. So what needs to happen to this guy right here?
Flip the bottom one.
Yeah, but keep that the
You have to
same.
flip the bottom one.
Okay, I'll flip the bottom one.
And then you divide the whole.
you divide it by 2, then you think.
So I flipped this one around so he became 15. And then what do I got to do to the top one now?
Divided by 2.
Divide it by 2. Okay. So that's going to be 2b plus 3 over 2e yields 2c. And I divided that by 2. So what do I have to do to my enthalpy?
Wouldn't it yield 1C because you divided by 2?
Yeah. That'll cancel out.
All right. This cancels out. That's going to leave me with my 2b and my a. It's going to leave me with my c and my 2d. So then all I have to do is add these together. And I'm done.
I like this one. I'm still trying to wrap my head around this.
Olivia, you are a rock star.
All right. You guys have homework for this weekend.
When is class end?
Time.
1 minute.
1 minute.
Wait.
Okay. You have your progress check and you have your 6-9. I will see you on Monday.
I was thinking when I was sitting down there, I was sitting down.
So you got
They like,
40.
they turned me and they're like,
Really? That's a solid D.